we'll do hydrocarbons simultaneously. So what we did was, I'll share this board link. This board link looks kind of more complete. So let me just share this board link. It has more stuff on it. Okay, I'm sharing this in the messages in Zoom. So now this one. Yesterday we did electrophiles. I told you that electrophile is something that is attracted to negative charge. And not only is it attracted to negative charge, so it can also accept a pair of electrons. So if there's X, it's going to be attracted to electrons and it will accept them. So X would be something that is electron deficient. It either has a positive charge, it's got a slight positive charge, or it would just simply be electron deficient. That is what X is. And we talked about, I've written down all the other stuff as well. A nucleophile is something we weren't talking or discussing about nucleophiles at the moment, but we did this mechanism, which was that all these addition reactions of alkenes had several addition reactions. So all of them had they had this mechanism, which was that alkenes have a pi electron cloud, and the bromine molecule, which is initially non-polar, it's going to get polarized. The electrons over here will be repelled further away. This bromine would become negatively charged, and if it becomes negatively charged, it's going to get repelled even further away. So the negative bromine will break away, and the positive one, the one that is electron deficient. But why is it electron deficient? Because the electrons over here are getting repelled. So the positive bromine will be attracted even more to the electrons that are over here. So the positive bromine goes and takes away the pi electron cloud, which was over here, and bonds with it. And so it forms a carbocation. And in the next step, the Br-1 comes back and ends up forming this other bond. So it's a two-step reaction where in the first step, one of the positive bromines ends up taking the pi electron cloud and ends up bonding with the carbon atom by using that pi electron cloud, and the carbon over here becomes electron deficient, and then the Br-1 comes back attracted to this carbocation. So anyways, let's try.
Sir?
Haji.
Sir, ये heterolytic होगा या homolytic?
This is heterolytic bond fission. ठीक है, heterolytic कल हमने explain किया था कि what was there are two types of bond fissions. One of them is homolytic, that the bond breaks equally. Equally का मतलब है कि the electrons they get divided between the two atoms. Homolytic is heterolytic is the other one, जो नीचे वाला, that's heterolytic, where both electrons they end up with just one atom. ठीक है? So both electrons they end up. So both electrons they end up with one atom, and it usually results in the formation of ions. And so now,
Sir? So normally heterolytic कौन से like alkenes में था, alkenes में था या homolytic किसमें होता है normally?
नहीं, अभी तो हमने alkenes का पढ़ा है. Alkenes is always heterolytic, क्योंकि जो bond नहीं था ये वाला, these electrons they repel these electrons, so all the electrons they got pushed downwards. So that means it's a heterolytic bond fission. The bond is breaking unequally. ठीक है? One of the bromine is getting both electrons. Is that clear?
Yes.
अच्छा, चलो वो किधर है हमारा? Where's the I said now in this one we'll probably do free radical substitution. Maybe the next question is about we did the first question. Now this next question is about free radical substitution, and he's talking about ultraviolet light. So let's discuss that in a bit more detail. So this was about alkenes. Alkenes had all these addition reactions. It had bromination. It had hydrogenation, where hydrogens would get added to the double bond. There was hydration, where water will get added, H and OH will get added, and so on. The next one that we are going to do, the detailed mechanism that we are going to do is the reaction of alkanes, the free radical substitution. We'll talk about its mechanism. How does chlorine in UV light reacts with alkanes and ends up substituting one of the hydrogen atoms or multiple hydrogen atoms or all of them. And how does it form a byproduct, which is HCl? So let's talk about this mechanism. So now this one is, so let's talk about free radical substitution of alkanes. And remember, I told you that it not only happens with alkanes, it happens with all alkyl chains as well. Like wherever you see a carbon chain, free radical substitution is going to happen with it. So it's going to happen with any carbon chain. Now, the reaction which we have over here is it's kind of simple. It's simply one of the H's getting substituted by Cl. That's pretty much it. But the mechanism is kind of really complicated. Now, the mechanism is divided into two parts. Starting with the first part, that's known as initiation. Initiation is the step where free radicals are formed. So the question is, what is a free radical? And how is it formed? We did answer this. We did write the definition of free radicals right underneath this. So this is what a free radical is. A free radical is usually represented by a dot, by a single dot. It's a species that has unpaired electrons. It's very reactive, and what we mean by unpaired electrons is that its bonds are not complete. Like if you look at a Cl atom, just a Cl atom, what you'll notice is that if you look at all the orbitals, one of the orbital has one electron missing. So it needs to bond, it needs to form one bond, it needs to fill this orbital somehow. So that means Cl is a free radical. Cl's outer shell is not complete. So anything whose outer shells are not complete, it's a very unstable substance. And it will try to complete its outer shell at all cost. So Cl is one example of a free radical. The CH3 molecule is also a free radical. Like if you look at a CH3 molecule, carbon shares 4 electrons or needs 4 electrons. So carbon itself has like if I keep this slightly. Anyway, so carbon has 4 electrons. So that's 1, that's 2, that's 3, and that's 4. This is carbon in the middle. Hydrogen has 1 electron, exactly. There's this other hydrogen atom that also has exactly 1 electron. And there's this third hydrogen that also has exactly 1 electron. So these are all my hydrogen atoms, but there are only 3 of them. Carbon needs 4 electrons to complete its outer shell. So if it only gets 3 of them, one of the orbital is still unpaired. It's getting 3 electrons from 3 different hydrogen atoms. One of carbon's orbital is still unpaired. Like if you want to look at it at the orbital level, carbon's outer electronic configuration is 2s1, 2px1, 2py1, and 2pz1. So 3 of the orbitals have gotten electrons from 3 different hydrogen atoms, but the 4th one is still unpaired. So that means it would be very reactive. It would try to gain electrons from somewhere. So any molecule or any atom or any ion, even if its outer shells are not complete and its orbitals are unpaired, that means it's still waiting for bonds to form, and its outer shell, its outer octet is not complete, so it will continue to attract electrons from other atoms. Is that clear? Like the CH3 will try to attract, if there's a hydrogen going around, let's say there's another hydrogen, this CH3 will try to pull that hydrogen atom, and it's going to be very reactive. It's going to try and bond, and it's going to try and make the fourth bond. Once it makes the fourth bond, now it no longer needs electrons. It doesn't even have space to keep electrons now. So now it's not going to be very reactive. But before that happens, it's going to be, before that takes place, this thing will be extremely reactive. Is that clear? TK, is that clear what a free radical is?
सर
हाँ जी.
सर इसके अंदर पेयर होना जरूरी है इलेक्ट्रॉन का?
Unpaired. क्या ये भी पूरी डिस्कशन उसके ऊपर थी ना, क्या अनपेयर्ड के ऊपर? कहाँ गया फ्री रेडिकल? It should have unpaired electrons. कहीं ना कहीं कोई इलेक्ट्रॉन खाली पड़ा हुआ है ऑर्बिटल, इट्स अनपेयर्ड. समझ आइए?
यस.
अगर if all of them are paired, सारी paired है, तो फिर तो उसको इलेक्ट्रॉन चाहिए ही नहीं है, फिर तो उसको नहीं चाहिए इलेक्ट्रॉन्स. मतलब let's say I have Cl minus 1, right? So if I have Cl minus 1, तो that means इसको इलेक्ट्रॉन मिल गया ना. ठीक है, 1 plus 1, it's got an extra electron. So now it's paired. Now it's not going to be very reactive. It's not a free radical anymore. Clear path?
Yes.
The Cl minus 1 is not a free radical. The Cl atom is a free radical. Okay. Similarly, so anything whose bonds are not complete, like OH. Okay. Let's say I have oxygen. So there's this oxygen atom and there's this H atom. Oxygen has 6 electrons. So that's 1, 2, 3, 4, 5, and 6. Oxygen needs 2 electrons. So if it gets 1 electron from hydrogen, it's still unpaired. It still needs 1 electron. Okay, so OH is a free radical. Is that clear? Is that clear?
सर
हाँ जी.
सर तो लाइक वो जब फ्री रेडिकल के स्टेट में तब ज्यादा रिएक्टिव होता है, तो जब लाइक उसे आखिर में मिल जाता है इलेक्ट्रॉन तो फिर वो रिएक्टिव नहीं रहता.
हाँ, क्योंकि अब तो इलेक्ट्रॉन मिल गया ना, वो दूसरे एटम के पास जाके क्या करेगा? उसके पास तो इलेक्ट्रॉन रखने की जगह ही नहीं है. If Cl minus 1 is formed, so it's not going to be reactive क्योंकि its outer shell is now complete. So even if it wants to get electrons or gain electrons, it won't be able to gain electrons. बात clear है?
Yes.
So anything is reactive until its outer shells are incomplete. As long as they're incomplete. As soon as they're complete, they would become stable. They would be unreactive because they can't gain electrons anymore. Anyways, initiation, that's the first step. Initiation is where the free radicals are formed. What happens is that the UV light, it breaks the Cl2 molecule, Cl2 bond, and it does it homolytically, which means equally. So there is homolytic bond fission that will happen. This is the equation that will be used. There's going to be a Cl molecule. UV light is going to fall on the Cl2 molecule. So let's say there's ultraviolet light. The bonded electrons are going to gain energy from that. And the Cl2 molecule is very susceptible to UV light. And what will happen is that 1 electron will go back to 1 Cl and 1 electron would go back to the other Cl. So that is basically homolytic bond fission. And this would result in the formation of 2 Cl atoms. And both Cl atoms would be radicals. They would be free radicals because they have 7 electrons. They have unpaired electrons. Okay, so is that clear? Math clear hai, Sidra? Rizwan, Tanya, is this clear?
सर
हाँ जी.
सर तो इसका मतलब एल्कीन के अंदर हेटेरोलाइटिक फ्यूजन होगी और एल्केन्स के अंदर होमोलाइटिक फ्यूजन होगी.
हाँ, मतलब एल्कीन में भी होमोलिटिक हो सकती है. ये नहीं कि इट्स नॉट गोइंग टू हैपन. हमने जो रिएक्शन पढ़ना है ना, विच इज इलेक्ट्रोफिलिक एडिशन, In that specific mechanism, ye wala, in this specific mechanism, it's heterolytic bond fission. This is the only one that we are studying in the course. Okay? So it's not ke uske andar ho nahi sakti. There would be some reactions where homolytic fission would also take place, but the electrophilic addition, bromination, hydration, and with hydrogen halides, the reactions that we are doing, that would be heterolytic bond fission. Or alkanes ke andar, the reaction that we are basically discussing, which is free radical substitution, that is homolytic bond fission. Okay? Clear?
Yes, sir.
Anyways, moving on. So the next step is propagation. Now, the propagation step is where the total number of free radicals, they kind of remain the same. So in the propagation step, total free radicals remain unchanged. No new free radicals are produced. I mean, new free radicals are produced, but the number of quantity of free radicals, it kind of remains the same. So free radical amount remains constant. It remains the same. Now, this is what's going to happen in propagation, that you will have an alkane. Let's say I have an ethane molecule. So here is an ethane molecule. And there's one more H. Now, if you look at this ethane molecule, it's got all these covalent bonds. The hydrogens are bonded to the carbon atoms. So there's a bond over here. The hydrogen is sharing electrons with the carbon atom. And the Cl radical attacks it. The Cl is kind of very electronegative as well. The Cl needs electrons because remember it had 7 electrons in its outer shell. It needs an electron. Its electrons are unpaired. Cl's outer shell is incomplete. So what it will do is it sees hydrogen's electron. So it's going to try and gain that electron and try to pull that electron towards itself. And it will try to bond with it. So H instead, what will happen to H is H is sharing electrons with carbon, but Cl is pulling that electron towards itself. So what would eventually happen is that the H, instead of sharing electrons with the carbon atom, will start sharing electrons with Cl, and an HCl molecule will be produced. So this is the product of the reaction, that the Cl, which is very electronegative and it's very reactive, it needs an electron at all cost. So the hydrogen atom in ethane, gets pulled by the Cl. So it gets pulled by the Cl, and the hydrogen, instead of sharing electrons with carbon, it ends up sharing electrons with Cl. And that's how the Cl radical becomes an HCl molecule. It gets its electrons. Okay, is this idea clear so far?
Yes, sir.
And
हाँ?
हाँ जी,
सर रेडिकल मॉलिक्यूल में कन्वर्ट हो जाएगा?
हाँ, तो उसको एक इलेक्ट्रॉन चाहिए था ना, ये था ना रेडिकल. Cl किधर था? कहाँ पे रेडिकल लिखा था? This was a Cl free radical. ना Cl का जो electronic configuration थी, its outer shell had 1 electron missing, right? मतलब Cl के outer shell में it has 7 electrons, right?
Yeah, yes.
अगर उसको एक इलेक्ट्रॉन मिल गया कहीं से भी, तो it's no longer a radical and it's going to become stable now. ठीक है? Is that clear?
Yes, sir.
Acha, but what will happen to now the question is, what will happen to the carbon atom? So H, instead of sharing electrons with the carbon, that electron got pulled by the Cl. So H started sharing electrons with the Cl. So carbon has an unpaired electron now, and carbon is now the radical. So this electron over here goes back to the carbon, because the H took its electron. Instead of sharing it with this carbon atom, it started sharing with Cl. So the carbon is now a radical because its bonds are now incomplete. So this is now a very reactive ethyl radical. So that's now a very reactive ethyl radical.
सर
हाँ जी.
सर हाइड्रोजन के भी रेडिकल बन सकते हैं?
नहीं, इस केस में the thing is कि वो हम एंड में ना प्रूफ भी देंगे इसका कि in this case hydrogen radicals can form. I mean, there's no reason why they can't form. But in this specific reaction scheme, hydrogen radicals are not produced. वो शुरू में क्या होता है कि it's the Cl radicals that are produced. Cl radicals are kind of the ones that are catalyzing the reaction. They go and they attack the H, and they could have attacked any H. I mean, I could have had a free. I mean, the free radical could be the carbon. I mean, this carbon could be a free radical as well. Like, let me show you another one. Okay, let's say I have this mechanism. I'm just showing that any one of the hydrogens could have been attacked. So which is why free radical substitution. Again, I did it on the wrong one. Just 1 second. Okay. So I just wanted to show you that any of the carbon atoms could have been attacked by this Cl. So maybe the Cl radical went and it attacked this particular. So this Cl had an electron, and it could have gone and attacked this hydrogen. Okay, uske electron ko na, it goes and pulls that electron towards itself, and the Cl comes along and bonds with that electron. Okay, so the point I'm trying to make is that it could be any hydrogen atom that the Cl could attack, and the carbon would get its electrons. The carbon would get its electrons back. So in this case, the radical that would be formed would not be on this one. I mean, this would still be H. In this case, this H would be lost, and the radical that would be formed would be on this carbon atom. So the Cl is attacking some other hydrogen atom. So the reaction is kind of the same. It's the same. It's the direction is different. Cl attacking this H, or the Cl could be attacking this H over here. Is that clear?
सर
हाँ.
सर तो लाइक वो स्पेसिफिक नहीं होगा, तो लाइक जहाँ से वो इलेक्ट्रॉन लाइक छीन लेगा तो वही कार्बन रेडिकल बन जाएगा.
हाँ, इसीलिए वो था ना कि ये रैंडम रिएक्शन क्यों था. The reason it was a random because Cl could get attached at any position randomly, right? So that's the first step. The Cl. So the thing is, the Cl can attack from anywhere, and it could take away any of the hydrogen atoms. And the thing is, just say वो hydrogen atom lega na, that is the one that's going to form a radical. So if it takes it from this carbon atom, the H, then this would be the radical. If it takes it from the other one, then that is the radical. Is this clear?
Yes, sir.
अच्छा, फिर ये कि एक सेकेंड. अच्छा, now the next part is what happens after that. Okay, once, okay, sorry, just a second. So the question is, what happens once this happens? Now the propagation step is 2 steps. I'm going to rub off the second step. I just wanted to show you what the second step was. So I'm going to just delete the second step. Let's put it over here. Well, let's keep it. just make it a bit smaller. So anyway, so the propagation step has two steps. Now you've got an ethyl radical, right? So I'm gonna take the ethyl radical, and it needs electrons somehow. Okay, so if you look at an ethyl radical, it definitely needs electrons from somewhere. So if it sees a Cl2 molecule, it's going to do exactly the same. That when it sees a stable Cl2 molecule, the carbon wants to bond with something. It wants its electrons back. So what it will do is it will take the Cl and pull it towards itself and bond with it. The other Cl would be left alone. So again, a substitution reaction will happen. And what you'll get is you'll get carbon with H's. The right carbon atom was a radical, but now it's got a Cl that's bonding to it. And another Cl radical is produced. Right? So it's a two-step process which just keeps on continuing. It's a never-ending reaction where the Cl radical attacks one of the hydrogen atoms, takes it away with it, forms HCl. The carbon becomes a radical. The carbon becomes a radical. It wants its bonds back. It attacks a Cl2 molecule and steals one of the Cl. So they're basically stealing atoms from each other. It takes away the Cl and the Cl radical is reformed. The Cl radical would now repeat the process. I mean, this Cl radical would do exactly the same thing again. It's going to repeat the process. So the propagation step would just continue. Now in the next step, the entire two steps are going to get repeated, except for the fact that if you look over here, one of the Cl is already in place now. So you repeat the process where you left off, but one of the Cls is already in place. So I'm going to repeat the steps now. Okay, this is my starting point. The Cl comes back. It's a radical. What it will do is it will try to steal one of the hydrogen atoms. So if it's able to do that, I'm not going to draw the arrows now, I'm just going to show you. So if it's able to do that, what will happen? So let's say it steals this hydrogen. So what's going to happen is that this molecule over here will have one hydrogen missing. The Cl is already there. This carbon would become a radical and HCl will be produced. Then the next step, now you've got a chloroethyl radical. This is, I mean, it's got chloro, so that's why we use the word chloro. The same process will repeat again. Now, this one needs to complete its bond. So what it will do is if it sees a Cl2 molecule, what it will try to do is it's going to try and steal one of the Cls and bond with it. So the chloroethyl radical, which is this one, will take one of the, its carbon needs a bond, so it will take one of the Cls and bond with it, and a Cl radical is again formed. Then again repeat. The Cl radical will again attack one of the hydrogens and take the hydrogens from it. So I'm just going to repeat it one more time. And let's just repeat it over here. So the same process repeats again. The Cl radical wants its electrons back. What it's going to do is it's going to take one of the H. So let's say this H is gone. So the molecule that's going to be formed is, let's just copy paste this. So the Cl comes in, removes one of the H over here. That becomes a radical, right? And the H goes to Cl and it bonds with it and it ends up forming HCl. So the HCl is formed. Now again, you've got this radical now. So this radical is going to attack a chlorine molecule and it will try to gain a chlorine from somewhere. So it just keeps on repeating endlessly and it repeats over and over again. So you've got a chlorine molecule now coming in. Same thing happens. This carbon needs a bond, so it steals one of the Cl. And as a result, a Cl takes that position. So the radical goes away because the Cl is now paired with it. And a Cl radical is again formed. And just keeps on repeating. So what is happening is, every time this happens, a chlorine gets added. So there are basically two steps which you have to remember. I did the first one with curly arrows, but now I'm not drawing those curly arrows. I just explained the first one. That the first step was the Cl comes in. Where did the free radical form? It was formed because of the UV light. Cl wanted to complete its bonds. Cl stole one of the hydrogen atoms. This thing became a radical. HCl was formed. This thing became a radical, so it then went and attacked a chlorine molecule, stole one of the chlorines and bonded with it. The Cl radical was again formed. The Cl radical was again formed. It then went again and attacked one of the hydrogen atoms, stole one of the hydrogens over here and formed HCl. And your ethyl radical was again formed. The ethyl radical wants to complete its bond, so it goes and attacks a Cl2 molecule. The Cl goes and joins with it, and a Cl radical is again formed. Again, the Cl radical is again formed. It attacks one of the hydrogen atoms, any one of them, takes it away with it and forms HCl. The carbon becomes a radical. The carbon becomes a radical, attracts a Cl2 molecule and steals one of the Cl, and the Cl radical is again formed. And the process will just continue to repeat. The two steps will continue to repeat. हाँ जी.
सर ये तब तक होगा जब तक सारे क्लोरीन नहीं आ जाते ना?
हाँ, तो मतलब this step will go on. There are two ways where this thing will end. One is that all of them become chlorine, so that's the reaction is complete, obviously. And there's another way. This other way is, it's known as the termination step. Just one second. So this other thing is known as a termination step. That's the third step. So this is propagation. Now in propagation, the total number of free radicals, they remained the same. Sorry. So you had a termination step now. So what's a termination step? Termination step terminates the reaction. So that's the third step. So imagine that your open a reaction is going randomly in, propagation is just randomly going on. Termination is that any two random free radicals could just join up with each other. I mean, why don't they just join up with each other? Radicals, they combine or they join up. I mean, basically what was happening in propagation. The Cl did not have, it had unpaired electrons. So it went and stole one of the hydrogen atoms, right? Why would it need to steal, let's say there are two free radicals now. I mean, there's a Cl radical. We know that there are Cl radicals. And let's say there's an ethyl radical. So there's an ethyl radical. Both of them are looking for pairing. I mean, they're looking for atoms to pair up with. So why don't they just make bonds with each other? instead of stealing atoms from other molecules which are already stable, why don't they just join up to each other? So that's another option. That's the termination step. If they do that, there would be no longer any free radicals. The free radicals would get used up and the reaction would kind of terminate. Because the reaction is only continuing as long as you have free radicals. If this Cl radical decided to steal one of the hydrogen atoms and form HCl, another free radical would be produced. But instead, if it goes and just bonds with this carbon atom that is already a free radical, the reaction is going to terminate. So if you look over here, there are lots of free radicals that are randomly getting produced everywhere, in every step. And you can think of thousands of molecules that are undergoing this propagation step. So there are all sorts of free radicals getting produced. Even in the first step, there's a lot of free radicals. There would be a lot of chlorine molecules, thousands of them, and free radicals getting produced. So any two of those free radicals could just simply join up with each other. So let's assume I have this free radical, right? So let's say I have this free radical, right? So why doesn't it just join up with if there is a Cl radical somewhere? Instead of the Cl stealing the hydrogen atoms, why doesn't the Cl just go and join up with that carbon atom? So, I mean, that's a possibility as well. So that's termination. If it does that, no new free radicals are produced. Instead, they all get used up. So if the Cl just decides to pair up with this carbon atom over here, that's it, the reaction ends. It's the termination step.
So,
हाँ जी.
सर दो क्लोरीन या दो क्लोरोइथाइल आपस में फ्री रेडिकल्स बना सकें? दो क्लोरीन आपस में हो या दो इथाइल हो, इस तरह से हो सकता है?
हाँ, इस तरह से भी हो सकता है ना कि let's say I have इसको कर लेते हैं कि let's say I have this thing, एक ये हो गया. And remember, this reaction is happening randomly. There are thousands of molecules. Every molecule is at a different step. So there are lots of different types of free radicals that are getting produced. One molecule is forming some other free radical. The other one is forming some other free radical. Okay? So there are lots of free radicals. So let's take this one. This is a free radical, right? And let's take some other one. Let's take this one, right? So this is also a free radical. दोनों को क्या चाहिए? They need one bond each, right? They need one bond each. So why don't they just go and bond with each other? I mean, instead of, so what they can do is they can combine with each other. The two carbons could just simply pair up with each other, and that's about it. फिर से गलत वाले वो कर दिया, एक second. So the two carbons would simply go and bond with each other, and that would be your free radical substitution. Okay, is that clear? So what will happen is, yes.
फिर प्रोपेगेशन के जो फर्स्ट स्टेप था उसमें आपने यूवी लाइट उसको दी थी, फिर उसके बाद
नहीं, पहला जो स्टेप
मतलब वो शुरू हुआ.
propagation का स्टेप नहीं था. Initiation is where the reaction gets initiated. UV light is the one that breaks the first Cl2 molecule, and that is where the Cl radicals are produced. ठीक है? So this is where the reaction starts, initiation. This is where the problem starts, that Cl wants to form a bond. It steals one of the H, takes it, bonds with it, forms HCl. The carbon loses one of the bonds. Now it's a radical. So the carbon decides to steal a Cl from the Cl2 molecule, forms a chloroethane. The Cl radical is again formed. The Cl radical again is formed. It steals one of the hydrogen atoms again, forms HCl. That becomes a radical again. That needs a bond, so it steals one of the Cl from the Cl2 molecule. The Cl radical is again formed. The propagation पे वहीं से start हुआ, and then at the last, somewhere in the middle, it might terminate. That any two radicals that are getting produced, they would just join up with each other, क्योंकि इसको भी एक bond चाहिए था, इसको भी एक bond चाहिए था, दोनों आपस में bond कर लें, बात खत्म. So if there are no more free radicals, the reaction is going to stop. ठीक है, is that clear? क्योंकि now it's a stable molecule, so no more free radical substitution is required. Is that clear?
जी सर क्लियर यस सर
अच्छा, anyway, so the thing with the termination step,
टर्मिनेशन मिडिल
hmm?
टर्मिनेशन मिडिल में कहीं पर होगा, मतलब आपने अभी बताया कि मतलब
किसी भी टाइम पे, और तीनों, रिमेंबर ये तीनों रैंडमली चल रहे हैं, ठीक है, तीनों साइमल्टेनियसली चल रहे हैं, all three are happening simultaneously. ये तो नहीं होगा ना कि मतलब let's say initiation is happening, right? तो ये तो नहीं होगा कि initiation will also happen 5 minutes later as well. मतलब let's say container के अंदर all these molecules are there, so you're not, I mean, UV light is still there. So if there's a Cl2 molecule somewhere 5 minutes later, 10 minutes later, it will still undergo initiation, right? So, I mean, there are tens of thousands of Cl2 molecules in the container. So every molecule will be breaking down into radicals at a different time. ठीक है?
यस
So propagation भी simultaneously चल रहा है. Propagation में all these radicals are getting produced. And then all of a sudden, somewhere in the middle, two radicals might just join up with each other. That's it. And that will terminate the reaction. Now, things that you have to be careful with is कि firstly, an H radical is never produced. Is never ever produced. Now, how did we know that the H radical is never produced? The way we know this is that if somewhere in any of the steps an H radical was produced, then two H radicals would get together to form what molecule? Let's say they terminated and they join up with each other. So they would end up forming an H2 gas molecule, right? Is that clear? Okay, if there is,
Yes, sir.
so if there is an H radical that is being produced, then in the termination step, two random H radicals might just join up with each other and they would end up forming H2 gas molecule. So in this reaction, if you look at the products, there is no evidence of H2 gas. H2 gas is never formed. There is no evidence of H2 gas. So that gives us an idea that the H radical never gets formed. Because if it were formed in any of the steps, then you would certainly have gotten H2 gas. Is that clear? ठीक है, clear है सारों को?
सर
हाँ.
यस सर
सर टर्मिनेशन स्टेप के अंदर दो फ्री रेडिकल जो होंगे वो 3 टाइप्स ऑफ मॉलिक्यूल्स बना सकते हैं ना?
बहुत सारे बना सकते हैं, मतलब इन्फिनिट पॉसिबल, मतलब इन्फिनिट तो नहीं है लेकिन बहुत सारी पॉसिबिलिटीज है.
नहीं लाइक एक है लाइक Cl विद Cl, एक है दूसरा आपस में जो है
नहीं.
इथाइल ग्रुप्स के आपस में.
हाँ, मतलब वो, लेकिन वो है कि इथाइल ग्रुप्स एक टाइप के थोड़ी हैं. देयर ऑल सॉर्ट्स ऑफ इथाइल. मतलब दिस वन इज डिफरेंट फ्रॉम दिस वन, राइट? दिस इज क्लोरो इथाइल, दिस इज डाइक्लोरो इथाइल.
ओके सर.
मतलब वो आगे जाके वो सब्स्टिट्यूशन होती जाएगी ना, सो there could be more and more Cls attached to it, right? So the ethyl groups could be of many different types. So either it's going to be ethyl radical attaching to a chlorine radical, or it could be two ethyl radicals. Okay, Achha, that's one. The second thing is termination products are a multiple of the original molecule, or they have multiple number of carbon atoms. So termination products have a multiple of the carbon atoms in the original molecule. They have an integer multiple of carbon atoms. Basically, what that means is of carbon atoms. What this means is, okay, if I start off with ethane or ethane has 2 carbon atoms. So I'm going to get a product that has 2 carbon atoms. Or I might get a product that has 4 carbon atoms as well. But I will never get a molecule that has 3 carbon atoms. So it's either 2 ethyl radicals bonding to each other, so that would make it 4 carbon atoms, or it would be an ethyl radical bonding to a chlorine radical, and that would form a 2 carbon atom molecule. I'm never going to get a 3 carbon atom or a 5 carbon atom molecule. It's always going to be an integer multiple of the carbon atoms. Is that clear? Okay, if I start off with ethane, I'm going to get either ethane, 2 carbon atoms, or I'm going to get a 4 carbon atom molecule. If I start with propane, which has 3 carbon atoms, I'm going to get 3 carbon atom chlorine substituted compounds. But I'll also get 6 carbon atom chlorine substituted compounds because 2 propyl radicals might join up with each other. Is this clear? ये वाली बात.
सर
हम्म.
तो ये क्या वो जो ये आप क्या कह रहे हैं कि डबल एच होंगे उसके पास?
कार्बन की मैं बात कर रहा था. ये मैं बात कर रहा था कि 2 कार्बन आटम वाला मॉलिक्यूल था ना हमारा.
यस सर.
तो प्रोडक्ट कितने कार्बन आटम का बना है? 2 का. ठीक है. इधर कितने का बना है? 2 कार्बन आटम वाला था, तो वो 2 जुड़ गए आपस में, तो कितने कार्बन आटम वाला मॉलिक्यूल बना है? 4.
यस सर.
तो मैं कार्बन
तो
आटम्स
सर
तो मैं कार्बन आटम्स की बात कर रहा हूँ. आई एम सेइंग कि your products, if you start off with a 2 carbon atom alkane, you'll get a 2 carbon atom chlorine substituted compound, and you might also get a 4 carbon atom chlorine substituted compound. ठीक है?
सर
हाँ.
सर तो ये क्या लाइक इसका एक एविडेंस होगा या प्रूफ होगा इस रिएक्शन का कि वो डबल बन रहा है उसका कार्बन?
नहीं, उसका प्रूफ तो नहीं है, मतलब उसका प्रूफ नहीं, मतलब बस वो ऐसे एक फैक्ट बता रहा हूँ कि आपको 3 कार्बन आटम वाला प्रोडक्ट नहीं मिलेगा. देयर इज नॉट गोइंग टू बी एनी मॉलिक्यूल दैट्स 3 कार्बन आटम because a 2 carbon atom radical will join up with a 2 carbon atom radical, so it will end up with a 4 carbon atom molecule. ठीक है? तो मतलब फैक्ट है कि if you're doing it free radical substitution of ethane, so your products will either have 2 carbon atoms or they will have 4 carbon atoms. बात clear है?
यस सर.
तो इस पे हम फिर we'll talk further on this in the next class then. ठीक है? Tomorrow. Let's leave it here. I'll discuss this in more detail, especially for propane. I'll do this. Okay, the termination products have an integer multiple of carbon atoms of the original molecule. Let me just complete this. Integer multiple of the original molecule. So let's continue tomorrow. Okay, everyone. Love is.